The squeeze theorem. This is an important theorem about limits that actually helps us evaluate certain difficult kinds of limits. What it says is that if f of x is less than or equal to g of x is less than or equal to h of x, or in other words, g of x is always between f of x and h of x, when x is in the vicinity of c, when it is near c, and if the limits of both f and h as x approaches c, if both these limits approach some number L, then g, the limit of g as x approaches c, also has to approach that number L. So in other words, if a function is between two other functions and those two outside functions are both approaching the same limit, then the in-between function is necessarily going to be squeezed into equaling that same limit. So let's use the squeeze theorem on this particular example here, the limit as x approaches 0 of x squared times cosine of 1 over x. Now you might be tempted to try and break this up into a product. Limit as x approaches 0 of x squared times the limit as x approaches 0 of cosine of 1 over x. The trouble is that this latter limit does not exist. And so we can't use a simple product here. So we're going to have to use the squeeze theorem. So what we know is that the cosine of 1 over x, in fact the cosine of anything, has to be between -1 and 1. Okay? As it turns out, if you just looked at that particular function, cosine of 1 over x, it would start to bounce back and forth between 1 and 1 infinitely as you approached 0. But we don't need to worry about that. It's always going to be as low as -1 or as high as 1 or somewhere between them. And so now we can multiply all three of these expressions by x squared. So we see that the function x squared times cosine 1 over x is between the two functions y equals -x squared and y equals x squared. Well, of course, the limit as x approaches 0 of -x squared is just 0. The limit as x approaches 0 of x squared is 0. And so by the squeeze theorem, that necessarily means if the two outside functions are approaching that same limit, then it means the middle function, which in this case is the limit of x squared times cosine of 1 over x, this has to be squeezed into equaling 0 as well. So that is an example of a use of the squeeze theorem.